Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as a result of the gravitational attraction of the Earth and the object. The gravitational potential energy of a massive ball of a demolition machine is dependent on two variables, the mass of the ball and the height to which it's raised. These variables are related and can be expressed with the following equation, where EP is the gravitational potential energy in joules, m is the mass in kilograms, g is the gravitational field strength in newtons per kilogram, and h is the change in height in meters. To determine the gravitational potential energy of an object, a zero-height position must first be arbitrarily assigned. Typically, the ground is considered to be a position of zero height, but this is merely an arbitrarily assigned position that most people agree upon. So if someone were to go to the top of Mount Everest, they would have a higher gravitational potential energy than if someone were to stay on the beach. If he were 85 kilograms, then his gravitational potential energy would be the height of Mount Everest, which is 8,848 meters, times by 85, times by 9.8, which is the pull of gravity from the Earth. So the gravitational potential energy of this guy is 7,370,384 joules. But this energy is just potential. If he were to jump off the peak of Mount Everest, then most of the potential energy will be transferred to kinetic energy. We can calculate his kinetic energy with the equation Ek equals a half times the mass times the velocity squared. If he was travelling at a velocity of 54 meters per second, then his kinetic energy would be 123,930 joules, but some of it will be lost as heat as well. This is why a pendulum and a clock eventually stops, because a small percentage of energy is being lost as heat with every tick.
He knows a lot about the science stuff, Professor Dave explains.
We now understand a more rigorous scientific definition of the word energy as being the capacity to do work. But as we said, there are a few different kinds of energy, so we must talk about all of these varieties. First, we will discuss kinetic energy and potential energy. Kinetic energy is the energy an object possesses by virtue of its motion. If we recall Newton's second law, we know that the application of some net force will move an object with some mass at some constant acceleration. We also know that work is equal to force times distance. So if we account for the distance traveled by this object, we get that W equals Fd equals MAD, or simply W equals MAD. We also know of this kinematic equation for an object experiencing constant acceleration. If we solve for AD, we get this expression, which can be plugged into the above equation for work. After some simplification, we arrive here, thus deriving the work-energy theorem. This term, 1/2 mass times velocity squared, represents the kinetic energy of a system. So now we can express the work-energy theorem by saying that when an external force does work on a system, the amount of work will be equal to the change in kinetic energy of the system. If W is positive, the system increases its kinetic energy, and the change will be equal to the work done on the system. If W is negative, the system decreases its kinetic energy, and this change will represent the work that is done by the system. Note the presence of mass in the kinetic energy expression. This means that if two objects with different masses are moving at the same velocity, the more massive object will necessarily have more kinetic energy. Now let's discuss potential energy, which is forever intertwined with kinetic energy. Potential energy is the energy an object possesses by virtue of its position in a field, whether that is a gravitational field, an electromagnetic field, or any other type of field. If you lift a ball up into the air, you are increasing its gravitational potential energy as it moves farther away from the ground. If you release the ball, that potential energy is converted into the kinetic energy of motion as it falls. The closer an object is to the center of gravity of the Earth, the less potential energy it has, and as you pull it up and away from the ground, it gains potential energy because it has an increasing potential to fall some distance to the ground. It may seem strange to bestow an object with more energy just by lifting it into the air, but remember that we have to eliminate our prior conceptions of the word energy in favor of more rigorous definitions. The potential energy of a compressed spring or an arrow ready to be released from a bow is where the kinetic energy of motion comes from. It is like a kind of stored energy. In this course, we will frequently be discussing gravitational potential energy for objects on Earth, and for any object, this will be equal to the mass of the object in kilograms times the free fall acceleration due to gravity for the Earth times the height of the object in meters. The greater the height, the greater the potential energy, as this represents the work that can be done by gravity to produce the motion of a falling object. There is also elastic potential energy, such as with the spring or the bow and arrow, and we will discuss this later as well. For now, we just need to understand kinetic energy as the energy of motion, and potential energy as the energy of location. Let's check comprehension.